All right, I wanted to just work a little bit more going from exponential form to logarithmic form. So these are some extra resources for you if you should need it. And so remember, we're trying to fill in, let's write this up top here so you guys can see it. Log of base b of x equals y. All right, so only if it says b to the y equals x. All right, so this would be your x and this is your b to the y if you want to look at it that way. So if I want to write this in exponential form, I have log of 6. I know logs always equal my exponents, so I'm just going to put the 2 out there. And what's the only number that I haven't checked off? I've checked off this one and this one, so 36 must go there. All right. Same thing again. What's the base in this equation? So stop and think about it. Pause it if you need to. But my base in here is 2/3. So I'm going to have log of the base 2/3. What's my exponent? I know logs always equal my exponents, so 3 has to go there. So the only spot I have left is right there. Again, we can do that one more time. This is my base. This is my exponent, and this is my result in this case. So log base 3 of 1 equals 0. Okay, and it's just going to take some time learning how to go back and forth with this. Remember, you can always use my little memory tool that I used when I was in high school. So start at your base, head towards your equal sign, and end up at your last number. So see how that works out? I start at my base, I head towards my equal sign, and this is my last number. So that's the order I would put them in. All right? So that is some of the examples, a little bit more than what you had. Now, when we need to find the log of the value of each logarithm, we can't just stick that in the calculator, because if you look here, this log, what we haven't talked about, this is only log base 10. And look at our logs here. They're base 5 and base 4. So I can't just pop this into the calculator. So what we will come to learn in this unit is if I'm solving for exponential equations and I need to find that exponent, I'm going to go into log form. But if I start in log form and I want to solve that, then I need to go into exponential form. So this is log base b of x equals y. So we could set y here or x, any variable that makes sense to you. And so I'm going to rewrite this equation in exponential form. So my base is always attached to my exponent. So base 5, my exponent is unknown, equals 125. Well, 5 to the what power equals 125? We want to get our bases the same. So 5 to the y equals 5 cubed. So once your bases are the same, your exponents are equal. So y equals 3. So log base 5 of 125 equals 3. I can do that again with this one. Maybe you want to pause and see if you guys can do it first and then come back and check my work. But just for sake of video length and how long it takes for me to upload, I start by writing it in my exponential form. So base is attached to my exponent, and then it equals 32. Well, there's no base in 32 that can be base 4, so I must need to turn this to base 2. So 2 squared is equivalent to 4, all to the y power. And 32 can be written as 2 to the 5th. So this becomes 2 to the 2y equals 2 to the 5th. Now once these are equal, I can set my exponents equal and solve. So I get y equals 5/2, which really is the answer to this. All right. Again, let me know your questions. I put a survey on yesterday's assignment for the 10th that asks if you guys want a live Zoom webinar where we can do some of these questions. Just let me know, or email me, send me messages. I'll get right back to you. Thanks.